Okay, a few questions have been requested. That includes Test 1 4C, Test 3 7, Test 4 11, and Test 11 number 6. So I've written them out here. The first one is Test 1, question 4C. We've got 3 to the x plus 4 plus 3 to the x is equal to 2214. Now, this looks like a very difficult question, but actually there's a little trick thrown in here. First of all, we're going to apply an exponent rule. That's 3 to the 4 times 3 to the x. So that's our exponent rule. When you're adding the exponents, that's the same thing as multiplying powers as long as the base is the same. Now we have a common factor of 3 to the x. And so we can factor out 3 to the 4 and 1. See, if you multiply this out, you get the line above. Now we can divide that out. And 3 to the 4 is 81, plus 1 is 82. So we've got 82 on the bottom here. So 3 to the x is 2214 over 82, which happens to be 27. And you know that 27 is 3 cubed. That makes x equal to 3. So that was test 1, question 4C. Test 3, question 7. You have 50 meters of fencing, and you're going to put it against a wall, and you want to make an area of maximum enclosure. So we have a total of 50 meters here, and we're going to use an unknown length of wall. So if I don't know how much wall I'm going to use, I'm going to call that x. That makes this side here also x. Now, as far as these lengths go, the whole thing adds up to 50. So each of these are going to be 50 minus x divided by 2. Now you can verify this for yourself. If you were to add up 50 minus x over 2 plus x plus 50 minus x over 2, you will get 50. Basically, if I take a full fence length of 50 and take away x, I'm left with 50 minus x, and then when I split it in half for these two lengths, that's what that divided by 2 gives me. Now the area is going to be the length times the width. So the area is x times 50 minus x, all divided by 2. So that gives me x times 25 minus 1/2 x, or minus 1/2 x squared plus 25x. That's my area. Now I want to know what x value is going to give me a maximum area, and then I want to find that area. Basically, this is a quadratic. And the apex of this quadratic is the maximum area, because the whole thing is equal to the area. So if I can find the vertex, the y value of the vertex, that is my maximum area. So I'm going to divide out that negative 1/2, leaving me with x squared here, and then when I divide out a half, that's going to give me a negative 50. So I've got negative 50x. And then I'm going to take half of that and square it. So half of 50 is 25, and I'm going to square it. Gives me 625. So I will add and subtract 625. Then I'm going to get rid of this term from the brackets by multiplying by what's out here. So I've got x squared minus 50x plus 625 And if I multiply those together, I get half of that. It's going to be 312.5. And then this factors nicely. I don't need to do that at this point because I know that that's my y value of my vertex. So this is minus 1/2. That's going to be x minus 25 squared plus 312.5. So what that means is when I go over 25, then I'm going to be at a height of 312.5. And that's the maximum area I can enclose with 50 meters of fencing. Okay, the third question is test 4, question 11. And we're to find the intersection of the line y equals 2x plus 7, and the function f at x is equal to x squared minus 3x plus 5. So basically I've got a line, and I've got a parabola, and I want to know where they meet. So I want to know the x value and the y value for these points of intersection. The way we do that is simple. You make them equal to each other. If the y values are equal to each other, the solution to the equation that creates is going to be the x values of when they're equal to each other. So if simply y is equal to f at x, meaning their heights are the same, all we need to do is a little bit of work to determine the x values that make them the same.